In this movie, we'll take a look at the build path, which gives me complete control over the design of my investigation. I've connected a motion sensor to my interface. The motion sensor reports position, velocity, and acceleration of objects in front of it. In this case, above the motion sensor, I have a mass suspended on a spring. The mass is currently stationary, and the motion sensor reports that it's 0.206 meters away. In this investigation, I'd like to look at the motion of the mass as it oscillates back and forth on the spring above the motion sensor. So I'll choose the build path. SPARKvue allows me to design my first page of the Spark Lab using any of the templates along the right side. In this case, I'm going to choose the template that has a medium object on the left and two smaller objects to the right. And when I press that template, SPARKvue builds that page for me, leaving a placeholder in each of these locations. Now from the placeholder, I can choose any of 9 different types of displays. There are data displays that we've seen already in the show path, including the graph, digits, table, and meter display. There's an additional data display, the bar graph, which is great for categorical data. We'll take a look at that later in this investigation. To the right, I have a microscope icon. This allows me to use a video stream coming in from a connected microscope or webcam and grab frames from that and do analysis on those frames. In the lower left, if I have an existing photo or video, I can bring it in. This letter T allows me to add a text box, perhaps for notes during my experimentation. And finally, in the lower right, we have an assessment item that allows teachers to add assessments such as multiple choice questions and text responses from students. In my case, I'd like to add a graph on the left side, a digits display in the upper right, and a meter display in the lower right. These data displays begin not knowing what to display in them, so I'm going to go to the select measurement in each of them and choose to display the position coming from the motion sensor. I'm almost ready to collect data, but first I noticed down here on the bottom bar that the default sample rate for the motion sensor as set by SPARKvue is 10 Hz or 10 samples per second. In this experiment, I suspect the mass may move a little quicker, and I'd like to catch all of the detail of its motion. So I'm going to go into the sampling options and increase the sample rate from the default of 10 Hz up to 50 Hz. So I'll get 50 position data points per second collected once I hit start. So let me set this mass in motion. And I'll hit the start button in the lower left to begin collecting data. And I can see from the digits display and meter display that the mass's position is obviously changing quickly. I can barely see that from the graph as it's currently scaled, so I will open the graph tools and choose Scale to Fit to get a better view of that oscillation. All right, I think that's enough data, so I'll stop this first run of data collection. Now, when students see this data, many questions may arise. They might want to do different analyses on it. In my case, I have a question about what the period of this oscillation is. There are a number of ways I could analyze this, including the coordinates tool that we looked at in the last lesson, but I'd like to introduce a new tool, the curve fits. Now, the curve fits dialog allows me to select a particular curve fit, for example, a linear fit if appropriate for the data. In my case, I think a sine fit will work best, so I'll choose sine fit, press OK, and I can see that in red, SPARKvue has added the best possible sine fit to my data in blue. The parameters of this sine fit are listed here along with an indication of the error, so I can judge how good a fit it is. I think it looks like a pretty good fit. And from these parameters, I can tell that the value of B is the period. So in this case, run number 1's period is 1.24 seconds with our current configuration. Now, I'd like to explore other configurations to see what might change the period of oscillation, but before I do so, I'd like to record my analysis so far. Now, SPARKvue has an embedded electronic journal feature that allows me to construct a journal of my investigation as I go through it. To add this page to the journal, I'm going to go into the upper right and tap on the snapshot button, which looks like a camera, and this takes a snapshot or a screenshot of my page with my current analysis. So now that I have that preserved, I'm going to change something about my experiment. In this case, I think I'm going to use the same mass, but change to a slightly stiffer spring. All right, so let me set this mass in motion. Again, the same mass on a slightly stiffer spring. I'll press Start to begin recording run number 2 of my data, and I can see it appear in my displays in red. I'll press Stop, and now I'd like to do a similar analysis to determine the period of run number 2. So I will apply another sign fit. And in this case, from the sign fit parameters, I can see that it does indeed have a different period. In this case, the period is 1.13 seconds. So I'd like to preserve this in my journal as well. But before I do so, I want to recognize that the snapshot simply takes a picture of the page. So I'd like this page to look a little bit better for this particular run. So I'm going to go up to my legend and click on the legend, at which point I'll see that there's a visibility checkbox to the left of each run. For now, I'm simply going to hide run number 1 by turning off its checkbox. I will scale to fit to fill the graph with my current run number 2 and its analysis, and I'll take a snapshot. So I now have 2 snapshots, one for each of my runs with analysis, and I'd like to show you the journal now, and it's in the journal that I'm going to begin my analysis and make some comments about the differences between these 2 runs. To access the journal, from the top bar, I'll hit the Journal button, which looks like a pen and piece of paper. And this brings me to the journal screen, where on the right side I see thumbnails of each of the snapshots I've taken so far. If I click on either snapshot, I can see a larger image of that snapshot to the left, and below the snapshot I have the opportunity to name the snapshot and add additional notes. So for run number 1, I'm going to label this snapshot and give it a name and indicate that this was the looser spring. And I'm going to record what I see up here as the period of oscillation, which was 1.24 seconds. I'll do a similar thing for the second snapshot. This is run number 2, the stiffer spring, and its period of oscillation was 1.13 seconds. And that's a shorter period than the looser spring. All right, to exit my journal, after I added some annotations, I'll press OK. One of the great strengths of SPARKVue is allowing students to engage in the practices of science, asking questions, designing and carrying out investigations to answer those questions, and communicating results. In this case, what I'd like to do is compare these 2 periods graphically, and I might want to go around to my classmates and gather some information about the springs that they used and the periods of oscillation that they discovered. So whenever I want to continue my investigation and I would benefit from having different displays, I can come up to the top bar and simply build another page after the current one. So I'll choose this New Page button, and this allows me to choose another template. For page number 2, I'll choose this full page template. On this page, I'd like to make a bar graph. So I'll choose bar graph, and I'd like to define the axes of these bar graphs, so I can hit either the X or Y axis. And instead of displaying data direct from the sensor, in this case, I'm going to make my own categories and look at the period of oscillation to plot on the Y-axis. So for the X-axis variable, instead of using a sensor measurement, I'm going to add a set of user-entered data. I will create that data set, and in this case, it's going to be the spring type. Similarly, for the Y-axis variable, I'm going to create a set of user-entered data, and this will be my measurements over the period of oscillation in seconds. Okay, I'm now ready to populate my bar graph. All I need to do is click on the first bar, and this allows me to edit that bar graph. In this case, I'm going to start with a loose spring, whose period was 1.24 seconds. And then I'll click on the second bar, and this will be the stiffer spring, whose period of oscillation was 1.13 seconds. Now, I have similar tools to those in the line graph, so I can come here and choose Scale to Fit to get a better view of those, and I can do things like add the values above these bars. Now, as I mentioned, as a student, I might want to go around and get similar data from my colleagues, and I could add an additional run to get the data from them, and for example, a different group may have gotten slightly different values. So I can record their values in this bar graph, and I could continue on with additional groups to make a comparison across lab groups. I'd like to add this bar graph to my journal, so I will take another snapshot, adding a third snapshot to my journal. Now I'd like to demonstrate how a journal can be shared. From this top bar, I'm going to go to the sharing options. And I have two options for my journal. I could either print a paper copy of my journal directly, or I could choose to export my journal. I'm going to choose Export Journal. And Export Journal allows me to create a journal outside of my current Spark lab. The nice thing about this journal is it's compatible with any web browser. So if I were to save this journal, let's say to the desktop, I would find the journal as a folder. The journal folder contains each of the snapshots I took, along with related text, and all of these things are wrapped up in a single HTML file that will open in any browser. So I could continue with this as a lab report, or I could hand it in to my teacher for grading. Returning to SPARKvue, I do have some other sharing options. If I go back to sharing, I could save the entire SparkLab file as a native .spk2 file, and this preserves everything about the file, including all of the displays, the data I've collected, and even my journal. So if I'd like a complete record or to continue my lab on a later day, I could choose to save the entire file, including on online storage services. And those storage services include things like Google Drive, Box, Dropbox, and FTP. There's a final option if I just want the data for my file. I can choose to export it, and this creates a text file that I can bring into other data analysis programs such as spreadsheets. So we've seen that the build path allows me to take complete control over the design of my investigation, and we've also looked at some of the options for saving and sharing my results. I'm going to end this investigation by going to the home screen in preparation for the next lesson.